We're on topic 4 of perfecting your pitch. And in this particular topic, we're going to cover creating slides part 2, specifically quantitative slides. Part 1 was on general comments and qualitative slides, and now we're going to get into data. The sections of this topic will include general comments, then go through various types of charts and graphs, and then cover some common mistakes and end with some examples of good practices. So we are in the sequence of our perfecting your pitch methodology on step number 3, create slides, where every slide is part of a story. So if it doesn't add to the value or the flow of your story, you better question what you're doing there. And there's do's and don'ts. The purpose of graphs and tables generally are to analyze, where you use data to gain insights, to communicate, where you're conveying a message forcefully, to monitor, where you're tracking performance, for example, over time or compared to other standards, and planning, to use data for forecasting and establish relationships. In this particular purpose, we're focusing on number 2, which is we're communicating. We're trying specifically to pitch to investors in order to get them interested in investing in our company. In Show Me the Numbers by Stephen Few, he mentioned various types of graphs. We're going to cover 6 different types in this particular presentation: scatter plots, line graphs, bar charts, box graphs, pie or circular charts, and bubble charts. You probably know many of these, but maybe not all. But we'll go through each one at a time. Let's start with a scatter plot. As the name implies, you scatter the data and plot it against the 2 dimensions of the axes here. And it's great to show dispersion and patterns. So we have 2 dimensions in this particular case. The horizontal axis is median age, and the vertical axis is the population increase. That we plot against those 2 axes, and in this case we're plotting different countries, and also in this case we use color to add another dimension, where colors represent continents or regions of the world. These graphs help see the correlation between the 2 dimensions. Here you see pretty clear correlation between the median age and the population growth. The more the median age is younger, the more population growth there is by country. Scatter plots are great for that. It looks a little confusing at the beginning, but your eye can process and your brain can process these relationships quite nicely. The second is the most common graph, which is a line graph. Here we have a vertical axis of population, and on the horizontal, time, measured in years. And here we see the population changes for bears, dolphins, and whales. We plot these against the 2 dimensions and we see the patterns, and this is particularly good in a case like this where we see that the patterns are different for different types of data that we're presenting. Here we see declining population of dolphins, rising population of bears, and a more relatively stable population of whales. Line graphs help see trends either singly or for multiple categories. Here we see for different types of animals. The third type of graphs is very common. It's a bar graph. Here on the vertical axis we have the frequency, and on the horizontal axis we have the vehicle color involved in total loss collisions. Not good, right? So here we have dimensions of 1 or 2 dimensions. Here we have 2 dimensions of color versus frequency. In this case, we have 1 snapshot in time, let's say a year. And we could have added a side-by-side bar illustrating another year. For example, we could have blue accidents in year 1, be 25, as is shown here, but we could also have shown what were the accidents in year 2 and see if there's any trends or changes from year to year. Here's a fairly simple bar, but bar charts generally are quite versatile depending on what you're trying to emphasize in your graph. Here we're comparing the frequency of accidents by color, and we can, as mentioned, add another dimension to see trends. Type 4 is not quite as common, but it's quite powerful once you kind of get used to how to interpret these. It's called a box graph, and we plot on 1 dimension, and here we show for 1 distribution the range, which is the high and low portions of the bar graph. And then in the center, where we see a box, the top of the box represents the upper quartile, which is the 25% range above it. And then the bottom shows the lower quartile, so where there's quantities below for the other 25%. And then the box represents, therefore, between the first and the upper quartile. And then the line in the middle doesn't have to be dead center in the middle, is the median, above which is 50% of the distribution, below which is 50% of the distribution. Often we use median instead of mean, which is a straight arithmetic average. Right? These are statistical measures that you'll become more and more familiar with. In this case, we look at one data set, and we put these we can also put them side by side, comparing two different stocks, for example, to look at volatility of their stock in a given year, or we could look at different stocks given the same year. So you could compare company A to company B for the same year, or analyze for 2 periods of time, 2 years, let's say, the performance of company A. And the value of this is showing the variability and the statistical measures that we often look at when we're looking at distributions. The fifth type of chart is a pie or circular chart, and these are also very common. Here we're looking at the population of countries of the EU in 2021 by percentage. And we look at the different countries, Germany down to the rest of the EU. Proportions, or the size of the slice of the pie, is the interpretive value, the analytical value. So we can see that Germany is, by quite a margin, larger than France, and then it goes in declining order thereafter. Stephen Few has very clear opinions about the use of pie charts, as does A.C. Ross. We'll cover those in a moment. Here we're just going through the overview of the 6 types of charts. The 6th type of chart is a bubble chart, and it's a very powerful tool, useful for 2, 3, or 4 dimensions of data, which is amazing, right? Because a normal graph has an X and a Y axis, and that means you have 2 dimensions of data. So let's see how this works. Oh, by the way, what is this graph called? If you look at it, it looks at market growth compared to market share, more specifically relative market share. This is called the growth share matrix, as made popular by the Boston Consulting Group. So this is used quite a bit in corporate strategy analysis, and it's been around for decades, and it's still a very powerful concept. All right, so how would we define these 4 dimensions? On the vertical axis, we show market share. The higher the better, right? So high market share on top, lower market share on the bottom. On the horizontal axis, we see something a little bit unusual, where we see that it goes low on the right to high in the left. So you got to be careful interpreting when you see something going counterintuitive like that. But the point is, if you have 2 dimensions, any point in that grid, that 2 by 2 matrix, represents 2 dimensions, relative market share and growth rate. But we have something else. The bubbles have different sizes. So the 3rd dimension of data is the size of the bubble. Size of the bubble would represent how much it represents, say, in sales. It's something that shows magnitude, right? So the dollar sales of, in this case, let's call them products, would be bigger bubbles for higher revenues, smaller bubbles for lesser revenues. And then the 4th dimension, not too well illustrated here, is if you color the bubbles. So some bubbles could be orange, representing one division or one geographic area. Other ones could be blue or purple or green or whatever. So the colors themselves convey a 4th dimension, which is an organization of the bubbles into groupings, typically divisions or geographic areas. And how would you add yet a 5th dimension? Oh my God, we got 4. How we add 5? The 5th would be time. And what would happen is, let's say we want to look at a bubble called Zantac, and we want to see, well, this is where we are now. Where were we a year ago? So we might plot last year's positions for the business units. And then we could see the movement, which ones are growing, which ones are shrinking, etc. Or you could use time dimension looking forward. So this is where we are now. Our strategy is to do X, Y, and Z in the future, hopefully achieving a position like this one. And you see a movement, hopefully up, in terms of market share of the various business units. So a very powerful type of graph called a bubble chart, and it's used for other things as well, where you're trying to convey multiple dimensions of information. Wow, that was a lot. Now how do we pick which graph to use which purpose? This is a highly condensed version of what's in Stephen Few's book, right? So bear with me if I'm seeming very compressed right here. If you want to read the entire information, go ahead and pick up the book, which I said is a great reference tool. So if you have nominal comparisons, just very simple comparing something over time or two competitors in a certain measure, you can simply use horizontal bars, vertical bars, or points, right? And there's no need, as mentioned earlier, that it has to be in order. You can have unrelated things like company A and company B, right? They're not time dimension, but you're just putting them and comparing them side by side. So that's a nominal comparison. A time series, which is, as mentioned, very commonly used. So we use vertical bars for a dollar amount or numbers, and then a horizontal bar going left and right with time, because our eyes and our brains are pretty much programmed to know that time starts with the left and then it progresses as we move right? So we use that typical orientation in graphs. There's no reason to be fancy or creative because we're just trying to convey the information on the graph, not necessarily the type of graph. And we can use points on that grid to show how many data points you have, or you can have lines that show kind of a progression, and it depends on the underlying data. The third scenario is your ranking. And the best way to show ranking is use horizontal bars going this way, where we show them in a sequence, like the longest bar, then shorter, and then shorter and shorter. And that way you can see very clearly, it's like a ranking, which has the most sales, then the next most sales, and then third most sales, etc. So horizontal bars are quite effective in conveying the ranking from high to low. Sometimes you want to show the part of a whole. And this is similar to the EU example. We want to show what part of the population of Europe is Germany. And we could do it with a pie, but as mentioned earlier, Stephen Few recommends that you use bar to visualize. And again, we could show them in declining order to show Germany's the largest, then France, etc., right? So that's a good way to do it. And you could do this for other measures like dollars or units as well. The next situation is where you want to show the deviation in terms of the variation from, say, an actual amount compared to a budgeted or expected amount. There we're not necessarily graphing the units themselves, we're showing the differences or the deviation, right, the change. So one simple way to do it is to have a horizontal line saying 0 deviation, and then graph the deviation up for positive deviations or down for negative deviations. So you could do that for something over time or comparing product to product. So the main idea is that the deviation from an expectation can be shown not by graphing the raw numbers, but by graphing the deviation amount itself. The next type is distribution, where you have a lot of movement in the data and you're trying to see if there are patterns and whether it is a tight distribution without a lot of variability or a wide distribution with a lot of variability. And that's an important aspect to know. So ways we could use, would it be a histogram, showing the frequency of different observations. For example, it'd be sales of donuts in a donut store, and you show the amount of deviation and see how variable would the sales be in that donut shop. And there, if you have a pretty tight distribution, you say, oh, it's pretty consistent. Or if you have a wide distribution, oh, it varies a lot day to day. So histograms, which graph the height being how many units you have, in this case donuts, would give you that sense of how predictable the sales are. The other way to do it is using a frequency polygon, where we show the percent orders over time. So here, staying with donuts, you can say how many donuts we sell as a percent of total donuts sold by time of day. So you start at 7 a.m. and you move toward the early afternoon and evening, and you show the accumulation percentages. You see, kind of get a feel for the flow of sales during the course of a day. So that's one that combines the amount of sales, but also a time dimension. The other thing you do is do a cumulative. So you could either plot them singly, like the percentages by time of day, or do a cumulative, how much is accumulated from 7 a.m. toward afternoon and evening. The next type of pattern is where we have multiple distributions. We have we can use multiple lines on a graph to show the distribution by different types of data. The other way is what we saw earlier, that box diagram. Here, one specific type is a box and whisker. The box is the variation within a certain range, like the quartiles. And then the whiskers, what goes above and below, show the entirety of the range from the highest to the lowest. Some people might be confused when you have too many elements on the chart, so you can dispense of the whiskers, which show kind of in that top quartile or bottom quartile, and just stick with the box. That the majority of the range of this particular measure is in the box, and then have a line in the box of the median, which is the number above which is half of the distribution and below which is the other half of the distribution. So it's what we commonly say is what's the average. Often statisticians like to use the measure of median. The next is correlation. We have two variables and we want to show the relationship of one to the other. An example is there a correlation between ice cream and the temperature outside? You would say yes, the hotter the temperature, the more ice cream you sell. So you could plot this in a scatter to plot the temperature on one dimension and the number of ice cream cones sold in a day. And you'd expect to see that on cold days, not as much ice cream. But as you move higher and higher toward temperature, you see more and more sales. So a scatter plot would be quite powerful. And if you wanted to get a little more rigorous analytically, you could try to see if there's a line that fits that pattern you see in the scatter plot. We call that a regression line, which is a formula that we can then apply to data to predict things. Say, oh, if we expect the temperature to be 80 degrees, how many ice cream cones do you expect to sell? And that regression line that is kind of cutting through that distribution might be a way to predict your sales of ice cream cones. Next is geospatial, where we're using geographic measures and seeing it visually. So an example would be you have a map and you have circle sizes of sales. Let's say you have a map of the world and the size of the circle represents your sale, and you see, oh, we sell a lot in Western Europe. Oh, we sell a lot in the United States, but not as much in South America or Africa. You can see that very clearly. Our minds are, again, programmed to know what a map is. And so the plotting of something on a map allows us to gather data on both the geographic dimension and, in this case, dollar sales. Similar to what we saw with the bubble charts, we can add color. So you could show circles, but also colors. And this would add another dimension. And so note, there are many, many other approaches that we see in the book, but are less commonly used. So I selected these to illustrate some commonly seen messages, if you will, that we want to convey. And then what type of graph best would apply to illustrate that particular observation. Remember, data is powerful when you're trying to convince an audience of a point, because you're giving information that hopefully is irrefutable. Therefore, if they see it and they see the data and they agree with the interpretation of or conclusion from that data, they'll be convinced as to your point. Right? Getting back to a slide, you have a title of the slide, you have the body of whatever underneath. If that whatever is a graph and the graph has data that's very powerful, then the audience will say, oh, I see the title, I see the data, and I agree with the presenter that this is a conclusion. A series of graphs and a series of slides that show substantiation of your points adds credibility and more persuasiveness to your presentation. That's why we love data. So often you'll see or hear the phrase data-driven. We were told that a lot at Bain. We want to be data-driven, which means clients like not just to know your opinions or your experience, but they want to see the data that supports your points of view. So that's why we like to have data to the extent we have data or can get at data through surveys and other mechanisms. So data can be very powerful in presentations, particularly to investors. You're trying to get money from them to come to your company. They need some substantiation and confidence that they're investing in a good company. Data is a very powerful tool to get to that conclusion. So let's avoid common mistakes. And I see these all the time. So listen to these and be the one that does not make these mistakes. First is do not put big numbers on the slide axis. For example, $10, 0, 000, 000, Don't do that. On top of that axis, put dollars in billions. Then you could just put 10 billion. Put 10. So the audience can see, oh, dollars in billions, it's 10. They don't have to squint and say 10, 000, right? It's lunacy. So make your units aggregated to a logical increment, like thousands, millions, or billions. Next is use reasonably spaced markers. Instead of showing tiny gradations of 17, 18, 19 up the scale of a graph, no, do intervals like 50, 150, whatever is appropriate given the range of values in your axis. And then don't use decimals. 123.45. That additional refinement to the 100th place is irrelevant. 123, 123 is just fine. I don't need to know down to the decimal point that particular item. Avoid 3D graphics. They're harder to read. They look kind of gimmicky. So keep it nice and simple. Similar to the first topic we had on qualitative. Keep it simple. And if you use colors, have them make sense. Red is for loss. Green is for profit, for example. If you use tables of numbers, help the audience understand and interpret by using colors or shading or highlighting so that they could follow the logic of that chart and which are the rows or columns that are most important. And also avoid embedding the entire spreadsheet. Summarize with a graph or table. Most often, audiences like to see higher level, aggregated, particularly something that's visual, like a graph, as opposed to a table of numbers. Here's something to look at and consider. The title is, Don't Miss a Massive Growth Opportunity. Question to you is, do you agree that we have periods 1 through 6 and we have measures that rise to 12,000 units? Is that a massive growth opportunity? For those of you who said yes, aha, I tricked you. For those of you who said no, well, congrats. You saw something wrong. Let's dissect it a little bit. The axis on this graph starts at 0 and it goes up to 14,000. And we're graphing the data points. Notice that the data points are 10,000, then rising to 11, then 12,000, which is, going back to the prior slide, the same. 10,000 rising to 11 or so, going to 12. So what's the difference? The difference is the bottom of this numeric dimension. It doesn't start at 0. It started at 10,000, which exaggerates the movement above 10,000. But it doesn't really speak to the actual volume of sales that you have. This is definitely more accurate. It's not as exciting or it's not as cool, but it's true. We're not trying to fool the audience. We're trying to inform the audience. So it's not as exciting to see this graph, but it's the truth that in this 5-year period, we've only grown from 10,000 to 12,000, 20% in 5 years. That's not a massive growth. So if you looked at the data, here's the actual data, and I graphed it, you're showing the lowest number is 10,000, which is wrong. That's a violation. And showing it with a 0 point shows the true depiction for the eye to view on the magnitude and the movement of the numbers. In my days at Bain, we used to have a shorthand for the top type of graph. We call it Time Magazine. Not to pick on Time Magazine, but they're prone to exaggerate or to make things look more dramatic than they really are. So they will do things with the axes by doing little squiggly lines that says, oh, we're not starting at 0. Don't fall for that. And more importantly, don't do that. Here's why. Yes, it's more dramatic, but what if the audience is discerning or a critical audience? They're going to see it and they say, you tried to fool me, didn't you? I don't appreciate that you're trying to fool me. I want you to give me the data as is and explain to me what you see. So I strongly advise against doing this, even though it looks more dramatic and might even work, but it may not work. And those are the instances that would be really harmful toward your credibility. The next don't is 6 graphs on one slide. Let's say you have a slide limit. You can only have 10 slides. Oh, I got it. I'll put 6 different slides on one graph. No. I'll put 6 different graphs on one slide. Ha ha ha. Aren't I clever? No, you're not clever. It would just confuse or maybe get the audience upset of you trying to work the system, if you will, by cramming 6 graphs on one slide. Don't do it. Oh, the only time you would put more than one is if you're showing the same conclusion with 2 slides. Like, this is a very powerful, profitable company, and you show one profit measure, like return on assets, next to another one, which is return on sales. Well, both are measures of profitability, and you're just showing that depending on how you look at profitability, they both give you the same conclusion, that this company is profitable. That's the only exception to having 6 things all here. I purposely picked things that have nothing to do with each other, right? So don't do this. Microsoft's wide selection of charts may actually not be very good for making your point. Here you have a graph. It looks like data. We have chocolate, strawberry, vanilla, and we have age groups like children, teens, adults. But what is the insight that you have? So in a way, think backwards. You say you have data. What insight do you want to convey with your graph? And then choose a graph that best illustrates what you're trying to make, instead of just poking around in Microsoft and picking graphs that look good. No, go the other way around. What is the message that you want from interpreting that graph? And which graph is best to show that, again, without cheating? Here's a good illustration of that. We have 2 graphs, and we say the iPhone 5S has cost of goods sold of $57 more than the iPhone 5C. Like, why is it $57 more? It doesn't make sense. You go, oh, here's data. Oh, we like data. On the left, we have the iPhone 5S. On the right, we have the iPhone 5C. And we call these donuts, by the way. It looks like a donut chart as opposed to a pie. I know we're going with heavy caloric desserts here, but this is a donut slide because there's a hole in the middle. If I ask the question, what is the reason the iPhone 5 costs $57 more to make than the iPhone 5C? You probably get it, but you don't get it immediately, do you? So let me try to illustrate how you could get it immediately. Maybe not as beautiful or cool looking, but much more effective. Oh, it's the casing, stupid. So what we've done here is done horizontal bars side by side by component. So you're not going up and down trying to figure out what slice of that donut pertains to the case, what slice is the processor, etc. No, we organized it by each of the components, the processors, the memory, the camera, the casing, etc. And very clearly, if you put the cost of the 5C next to the cost of the 5S, the casing is where all the money is. So we don't want to make our audience work. We want our audience to see the data and be convinced. So this is a far more persuasive graph than this. Like, I can't tell by looking at it. If I dug in, I'd see it. But this makes it obvious what the answer is. We want to be obvious so the audience agrees with us. That's the point. So there are some specific chart types that we're trying to avoid. 3-dimensional anythings. Here, a 3-dimensional pie. That third dimension makes it harder to see, right? Now, it's more illustrated on the next one. It's 3-dimensional on bar charts. And so you're trying to read what is the height of each bar. And it's hard to read because now you have that third dimension. The one on the right is weirdness, these cones. They don't really make the point very nicely. What is the point? Is there more density of the squid than the whale? Like, what's going on here? Or are you just trying to be fancy with a cone? And on the bottom left, there's this example of false precision. Look at that axis, 50.0000. Like, isn't it just 50%? Get rid of all those decimal points. Just put 50. The next one over, same thing, false precision. 60, 0.00, Really, do I care about the 0.00? No, I don't care about pennies. Do I really care about the thousands place? No, not really. Do I really care about the millions? Now we're talking. So you could easily have labeled this dollars in millions and simply put 10, 20, 30, 40, 50, 60 as the axis labels. Much easier to read. Now, mathematically, it's identical. I get it. But in terms of ease of understanding, much better to simply put 10, 20, 30, 40, 50, 60. And on the right, this is just chart junk, like having this airplane depict the bar chart in background. You can't even read the data very nicely. So don't make it fancy. Similar to the point made when we were in the qualitative section. Label your charts clearly. Here's an example of a not clear labeling. We don't have the items very closely associated with the lines. We don't even have the right colors. This is a mess. This is much better. You'll note that we have 3 colors and we're labeling right next to each of the lines, the scrolls, the nerds, and the widgets, right? And we don't have to be going left and right looking at legends and trying to interpret and remember. Just put the labels right with the graphs. So that's a much better way to show data, particularly when we're doing comparisons between one and another. Here's another example where it looks good, looks like a bunch of bar charts, and looks like a lot of people make decisions with others, but the point is muddled here. We don't really understand. So the way to improve it is to do stack bar by year. So you have 2012 next to 13, next to 14, and then you have the stacks represent sole decision maker to with others, with participate, with not. And then you'll see clearly how decisions are made over those 3 years. Okay, so this is what not to do. What should we do? Here's an example of a table where sometimes you need numbers. And here, what we're illustrating here is these shaded lines where you have subtotals. It draws the eyes to looking at the total headcount related costs and then the total professional service costs, right? So that shading helps the brain a lot. If you had no shading, you'd be looking there trying to interpret the indentations. It just would be much more difficult. So something as simple as shading or underlining or space could help the audience interpret much more easily. But some, and I would say most audiences actually prefer graphs. So something that shows something graphically over time is usually much better. All right, does this look okay to you? We have a company and we're graphing sales and profits and we say, oh, this is great. They're making more sales and more profits. That is one way to show the information, but let's look at the interpretive value of the data that you have. If we look at the sales growth rate, we actually see that even though the sales are growing in that straight line going up, the year-to-year growth rate, the percentage growth rate, is actually slowing down. And this is graphed on a scale called logarithmic, where we graph the information and a straight line is constant percentage growth. Any slowing down, kind of like this, kind of a concave shape, means that the rate of growth is slowing. So even though the data for the blue line here and the blue line here are identical, this is graphed on what's called a linear scale, right? Where equal spacing all the way up the vertical axis. Look at the vertical axis here. It jumps from 10 to 100 to 1,000. So their order of magnitude jumps. And this converts this interpretation, not unit change, but percentage change. And investors and a lot of people look at percentage change more than unit change. Here we're saying, oh, what looked nice and smooth in the prior graph is not so nice and smooth. We're actually slowing down our growth. That's not good. The other thing is to look at relationship. Instead of showing separately the profit and the sales, what if you got the ratio? The profit as a percent of sales, and we see that the margins, the profit margins in this case, are actually declining. So all 3 of these are the same data. But this is better to depict growth rate of sales, and this is better to show profit margin on whether the company is actually doing better or not. They may be making more profit, but the actual percentage margin is deteriorating. Here's just an illustration with a pie, picking picking on the pie diagram, right? We have this one with the different components of market share, and it's really hard to interpret. You could look at it, say A, B, C, all others, like how can it be improved? So here, let's do the after. This is the before, this is the after. So here we say there's one leading competitor, company D. Our company is in second place, but behind by a wide margin against company D. We can get that from looking at this, but it's nowhere near as clear as this graph. So in this particular chart, using the Stephen Few guideline of horizontal bars, rank ordered, is a powerful way to convey data. Here it illustrates it. Company D dominates our industry. We're in pretty good shape. We're second market share, but we're not that much ahead of the third place company by a fraction of a percent. And we have a long way to go to capture leading market share. Right? Very, very clear depiction. So the last series of thoughts are on fit and finish, similar to what we had on fit and finish related to the qualitative slides. But now we're going to add charts and graphs. We've covered the first page of this before on the prior topic, text and vocabulary with typos, etc. But now we're adding the charts and graphs. So lines are used for time series. Bars, where there's no implicit order of the information you want to show. Axes should always be clearly labeled. Horizontally, don't make people turn their head. And then axes should be scaled in logical increments, like 10, 20, 30. Lines, bars, and areas should be clearly labeled. Let's avoid legends if possible. I know Microsoft it seems to be more using legends, but putting labels near the data is better. And then numbers that are rounded to useful increments or significant digits is really important. So don't put needless amount of precision in there, particularly since it's probably not that precise anyway. No decimal points unless you're down in the decimal point area. There's a scorecard that's in the Perfect Pitch Playbook to evaluate and improve every pitch. So this shows some of the information to watch out for, and you might find this handy. This is something we will look at more closely when we're in class together. So that's topic number 4, creating slides part 2, where we looked at quantitative slides. General comments is data is very powerful and a very persuasive tool. Types of graphs, we looked at 6 types. Scatter parts shows correlation of the variables that we're choosing. Line graphs shows is particularly effective for time series. Bar graphs are great for side-by-side comparisons or showing proportion. And then box graphs are great to show dispersion around the mean or median. And the pie or circular, don't do them. Break that habit. And the bubble charts, they're powerful when you have multiple dimensions. Common mistakes are clutter, too much junk on the graph, or Time Magazine, where we don't start at 0, and a lot with non-obvious conclusions, where the graph is a graph, it's data, but it doesn't really highlight what you're trying to show. And examples of good practices are captured in our do's and don'ts section. That's it for topic 4. We have one more topic to cover, which is delivering persuasively. See you soon.